Hey everyone, today I'm going to show you how to use debugging in VScode, particularly on the C program. So I've been advocating the use of debugger ever since I've discovered it on the CS50 lectures. When I see a debugger, how the debugger was used in the lecture, I was absolutely fascinated and it just blew my mind. Well, its sole purpose is not just for debugging purpose, but I often use it as a tool for me to learn how the algorithm works in general, which I'm going to demonstrate shortly. Hopefully from this video I'll be able to show you how you can use debugger to enhance your coding experience. So without further ado, let's dive in. Alright, so before you do the debugging, you have to set up your system first with the GDB and also LLDB. Usually on Linux you will install GDB. Okay, if you have downloaded Ubuntu with your WSL enabled, you would have to install GDB first. Okay, it wouldn't come with the Ubuntu itself. You have to install the GDB, and LDB is optional. Usually on Mac, LDB is available on Mac if you have installed the Xcode. But in this tutorial, we're going to use LLDB. So make sure that you install LLDB. Okay, the reason why I choose LLDB over GDB is because of some issue with my GDB on Linux. I'm not entirely sure, but I do face some issue on the Debug Console where I'm not able to access the variable when I use GDB. So I found an alternative, which is using LLDB, and it works for me. So on this tutorial we're gonna use LLDB. They are very similar, just that the syntax might be a little bit different, but you can always look it up for the correspondent command if you are used to GDB. And another thing is the VScode extension. So do make sure that you install the code LLDB on your VScode. Okay, so once you have set it up, okay, we're ready to debug our program. Okay, so in the process of debugging, there are 3 steps in general, I would say, or maybe there are prerequisite steps that you need before you can debug your program. So for C program, as C as a compiled language, which means most of your program has to be compiled first before it runs. Unlike the script, the interpreted language, where it's constantly being interpreted and executed. Or for compiled language, you have to compile the program in one go. Okay, so when I started using debugger, particularly on the libft, I face a lot of issue because I don't know how to debug a multi-source file program. Okay, and I was looking around on the internet trying to find a reference that teach me how to debug the multi-file program, and I just couldn't find the right resources. So it took me quite a while. To be honest, it's like a few weeks to eventually find a way to do that. And the reason that I could eventually find a way is also because of a peer on 42 who's been generous enough. He doesn't want me to mention his name, but yeah, he has been very generous of helping me to figure out the solution. So what we're going to do today, we are going to debug a single file program, and also a modify program, and also a library. Okay, I'm going to show you how you can do 3 of them with a project in mind. We're going to take the 42 projects as an example. Okay. The next thing is the task and launch configuration. Basically, what the build task is, it automates that compilation for you. So oftentimes you have to compile your code. If you have changed it, you have changed your code, or you have modified your code, you have to recompile it. And that's what the build task is for, is to automate that compilation. Okay, it wouldn't be too difficult if it's a single file, but if you have a multiple file, you have to make some configuration first before you can run it. Okay, and the next thing is the target configuration. So this is where you're gonna attach a debugger here, debugger program, either GDB or LLDB. So I'm gonna show you that as well. Okay, in this case, I'm gonna use LLDB again. Okay, and we have some basics on debugging. So what are the interface like, and also the Debug Console, which I'm really excited to show you because it really extends the functionality of debugger beyond what is available on your Debug Sidebar. Okay. Yep. Okay, so we're gonna go to the VScode and see what we can do there. All right, so I think I'm gonna start with a single file program. So over here, I got a Factorial. So during the scene, Factorial, the recursive function, is one of a difficult function that I had hard time trying to understand. So we're gonna try debug a Factorial function. Okay, recursive function. Let me just delete this because I was doing some testing previously. All right. So here we got a Factorial function, right? So as a Factorial function is a recursive call. So as the function call itself, the call stack will actually grow, right? So let's see. So let's try to put some number in. Okay, let's put in number equal to Factorial. Maybe let's put 4. Okay, not to I don't put a big number, or else it's gonna have a lot of recursive call. And then we're gonna printf. We're trying to see what we get here. So digit. Right. So if you've been using VS Code, you know there's one thing that's called the code runner. So the code runner also helps you to compile and run it. You can use code runner. So the code runner will show you this is a 24. Okay. So what does the code runner actually does is it actually does the compilation for you. If you see that, if you look at this command here, it actually changed the directory to your workspace, right? And then it GCC and output this file and then execute the executable. Okay, So this will be generated. So this is what a code run do. But for you to use debugger, you have to do a similar things, which is a build task where you automate this execution as well. Okay, so let's see what happened with it. Okay, before that we have to put a breakpoint so that we can see what happened. We're gonna put a breakpoint over here. So let's try to see what happened over here. Oh yeah, well, there's one thing I forget to mention is the LLDB. So this one you have to go to extension. So this is LLDB. I would recommend you to download this one, code LLDB. Right. So before that, also remember to install the LLDB and GDB based on the link I send you, or you can just Google search installing GDB and LLDB. If you don't bother to use GDB, just download LLDB. Okay. So yep. Okay, so let's go to the debugger. Right. So as you run and debug, it will ask you whether you want to use GDB or LLDB. Choose the first one, and then this is the build. Basically, build. We're gonna build it with GCC or Clang 10. I think either one is okay. Let's try to use GCC then. Okay. So the launch configuration. This is using the. Oh, okay. This one is using GDB. So I guess we have to choose LLDB instead of GDB. Okay, so I need to recreate the task actually. What I do, I just sorry, it's a launch. I'll recreate a launch again. So I just press F5 again. I'm gonna use the LLDB. All right, it says that it's not provided. So one thing, what you have to do is you have to change it to file. Oh no, it's not file. It's the base name with no extension. So just grab this thing, copy this, and put it over here. All right. So now just press F5 again to initiate the debugger. Okay, there you go. So now we have this debugger sidebar where it's going to show you all the variable, the local variable, and also the static and global. If you have learned about the computer architecture, you learn about what this register is doing. Okay, basically it's it's about the value that's stored in the register of the processor during this step of execution. Okay, so if I would like to understand this code, I'd like to know how it works step by step, right? And there we have some interface here, which the first thing is continue. So what does continue do is it will, if I'm going to press this continue, this program is going to finish. It will exit because there's no next breakpoint to stop at. Okay, so what does it continue is it's going to execute the code until it see another breakpoint. But in this case, there's no next breakpoint after that, so it's going to exit this program. Yeah, and also printed 24 as a result of the code on line 13. So if I'm gonna set a breakpoint on this function, if I press continue, it will go to this breakpoint because this is what is going to happen next. Okay, And the other one, okay, so the second symbol is step over. So in this case, we can either choose to go deeper into this function, or we can just ignore this one and go to the next line of execution. So if we're going to press a step over, it's going to go to line 13. Okay, but in the contrast, if we press this step into, it will go into the most inner function. Okay, so in this case it's a factorial. So we're going to press this step into, it's going to go to this factorial. Okay, and also if you don't wish to continue on this loop over here, you would like to get out of this function, you can actually press step out. There you go, you come out from that function, and the return value is 24. Okay, so this is basically the basic interface on the debugger, and I've been using this a lot as well. Okay, we're gonna look more closely to the call stack. Okay, because in the recursive function, is what you have to understand is the call stack. And let's see. So what happens is I usually, if I'm trying to understand this, I'll try to go in as deep as possible. So I'll just continuously click on the step into. As the first call stack factorial, you can see the local variable is 4, and if I go to this return, and you see this thing is actually pointing to this function. So it actually care. It actually will execute this code here. So what happened is you create another call stack, as you can see. Now it's with the value of 3. But what happened to the previous call a function? Well, it actually stopped, right? So this is the one highlighted in green. Okay, it actually paused while waiting for the return of the return value of this function, which is a factorial 3 in this case. And you click again, the factorial 3 is executing this line of code and call another factorial. Now it's 2. Okay, as we can see, this green okay, this green means previous function. So at this point, when the number is 1, it will return 1. So what's the next? So it's going to return 1 and exit the function. Okay, now that the stack has been popped. Okay, and the next number is returning I think this should be is it 2, 2, 3? Yeah, it's gonna be 2 over here. Okay, at this point, I want to evaluate this actually. If we would like to evaluate the number, you can use this debug console. So there's one useful command is print, so we can just type p and you can put num. It's exactly what we're seeing here, but if you wish to look at a function, you could also use print factorial. This is a num. So currently the num is actually 3, right? You can substitute a 3 here, so it'll be 3 minus 1. Look at the value here. So this one is supposed to be 2, and if you would like to check that, you wouldn't be able to see it from this local variable. But what's useful with the debug console is it allows you to make evaluation on a certain function or a certain value. What amazed me is you can even look at the address of the variable. So for example, in this case, the num tree, when the num, this variable num is not the same as this num. Later we're going to prove that. Like for this one, I can actually print the address. Okay, so we're going to print the address of num, and this is the value. Okay, now if I'm going to execute the next step, and now the number is 4, and I'm just going to print this again, and you can see that this is actually not equal. Yeah, they're not equal. This is a hexadecimal, right? So I mean, they're, you can see the number is actually higher than this. Okay, so that means the cost stack is actually growing downward. Yeah, so as you get more cost stack, the memory allocated for the stack is actually growing downward, the address of the memory. Okay, because this is the highest stack over here. The number is lower, yeah, and this number is higher. Okay, and this is assembly. So if you know about assembly, you can probably understand what is happening over here. I do know a little bit, but it was very basic, so this one I couldn't really understand it like properly. So this one you don't need this. This is actually a call stack before the main function. Yeah. So at this point you can actually stop, okay, because you don't need it anymore. So this is for debugging the single file program.